Hello Ace, this is RetroTK2 and today we're looking at polymorphism in C#. If this is your first C# video, I'd strongly suggest watching the series from the start. Card should be on your screen now. And if you haven't already, might I suggest downloading the channel files that accompany this video. Card should be on your screen once again. So let's get started. What is polymorphism in C#? Well, according to the Microsoft docs, polymorphism is often referred to as the third pillar of object-orientated programming, after encapsulation and inheritance. Polymorphism is a Greek word that means many-shaped, and it has two distinct aspects. At runtime, objects of a derived class may be treated as objects of a base class in places such as method parameters and collections or arrays. When this occurs, the object's declared type is no longer identical to its runtime type. Base classes may define and implement virtual methods, and derived classes can override them, which means they provide their own definition and implementation. At runtime, when client code calls the method, the CLR looks up the runtime type of the object and invokes that override of the virtual method. Thus, in your source code, you can call a method on a base class and cause a derived class's version of the method to be executed. Virtual methods enable you to work with groups of related objects in a uniform way. They give an example using shapes Ace that we're going to cover a little bit later on in this video. Virtual members. When a derived class inherits from a base class, it gains all the methods, fields, properties, and events of the base class. You'll remember this from the inheritance video Ace. If you haven't seen it, please check out the card on your screen now. The designer of the derived class can choose whether to override virtual members in the base class, inherit the closest base class method without overriding it, define new non-virtual implementation of those members that hide the base class implementations. A derived class can override a base class member only if the base class member is declared as virtual or abstract. The derived member must use the override keyword to explicitly indicate that the method is intended to participate in virtual invocation. Fields cannot be virtual, only methods, properties, events, and indexers can be virtual. When a derived class overrides a virtual member, that member is called even when an instance of that class is being accessed as an instance of the base class. Virtual methods and properties enable derived classes to extend a base class without needing to use the base class implementation of a method. An interface provides another way to define a method or set of methods whose implementation is left to derived classes. We'll cover interfaces in another video Ace, so don't worry too much about that just yet. Hiding base class members with new members. If you want your derived member to have the same name as a member in a base class, but you do not want it to participate in virtual invocation, you can use the new keyword. The new keyword is put before the return type of a class member that is being replaced. Hidden base class members can still be accessed from client code by casting the instance of the derived class to an instance of the base class. We'll talk about casting in another video Ace. Preventing derived classes from overriding virtual members. Virtual members remain virtual indefinitely, regardless of how many classes have been declared between the virtual member and the class that originally declared it. If Class A declares a virtual member and Class B derives from A, and Class C derives from B, Class C inherits the virtual member and has the option to override it, regardless of whether Class B declared an override for that member. A derived class can stop virtual inheritance by declaring an override as sealed. This requires putting the sealed keyword before the override keyword in the class member declaration. Sealed methods can be replaced by derived classes by using the new keyword. Accessing base class virtual members from derived classes. A derived class that has replaced or overwritten a method or property can still access the method or property on the base class using the base keyword. Okay, yes, an absolute bucket load of information there, but we're going to go through each little point separately. So let's get stuck in. Open up Unity and create a basic C# script. As always, make sure you give your script a different name than any other class in your project. I'm also going to be using Unity Spice here. Yes, please feel free to download it yourself by following the instructions after you clicked on the card on your screen. If you follow those instructions, you should be able to get a free version of Unity Spice. Okay, so polymorphism is, as the doc sort of described, a derived class being used as if it was a base class. So let's go with the shape example that the docs used. So let's declare a very basic class and let's call this shape. Now you could make this class abstract is, but I kind of want to leave abstract classes for the moment. Essentially an abstract class is usually a class that you don't necessarily want to instantiate. But again, it's not necessarily that important. So we have a shape class. And as you know, then we could have many different classes that inherit from shape that are shapes themselves, but have more specific implementations. So for example, we could have rectangles, and we could have squares, and we could also have circles, just to put a bit of a different spin on the whole thing. Okay, so what's sort of common amongst all of these would probably be, well, if we think about basic shapes, you'll probably need a way to get the area. So if we did that as a float and just had it as area and make it a get set. Perfect. And another one would probably be, guess we would have length. I kind of want to say length, but I'm kind of thinking about in terms of circles. Length's not important, actually. We would say perimeter. Sorry, yes, my spelling is absolutely abysmal, as you can see. You've come to expect that by now, maybe. Perimeter. Oh my goodness, yes, I should have got that one. Okay, cool. So anything else that a shape would have? I suppose it would, yeah, area and perimeter is a good one to go for the moment. So, okay, so that's a pretty good place to start this, but of course we want to override these methods. We don't necessarily just want them to be sitting the exact same as they were. So we want to put in our virtual keyword because we don't want these to necessarily be the inherited versions of themselves. So let's try and take this away. Auto properties must have a get and a set, so we can't just quite do that. We can do that, and because let's not forget is we don't necessarily want the set. I suppose we could have it so that we could set the parameter or the perimeter and the area, but as soon as you do that there, then you've got to put in where it'll actually try and guess our length values or whatever that we have for these things. And I mean, I really got to be honest with you, yes, I definitely don't want to do that at all. So we're just going to stick with the gets. I think the gets will be cool. Okay, so rectangle will inherit from, of course, shape. And we can, of course, instantiate a new method or whatever and do all that fun stuff, but that's not necessarily going to work for us here because, well, I mean, it won't be able to do anything because whenever we call error, all we're going to get back is a 0 and a 0, of course, for the perimeter and the area. So what we want to do instead is create a constructor for our rectangle, and then we want to pass in the actual lengths that we want. So we want width, and we want, I believe it's length, width and breadth, isn't it? Breadth. Oh dear, yes. Again, the exceptional spelling. No, don't do that. Breadth. I believe that's it, yes. By all means, tell me if I'm wrong. And we want to definitely make sure that we create read-only fields for these. Okay, so now that we've got our actual fields, we can now override our virtual members. So override, and then we want to do float, area, and we want to put in our get. Okay, so whenever we return, well, we know how to get area. The area of a rectangle is width multiplied by breadth. And that'll do. Brilliant. And then parameter, of course, is all of the sides added together. So with this, we want to override float and parameter. Yeah, that's perfect. Get, and we want to return 2 multiplied by width plus 2 multiplied by breadth. Now, if you've done any sort of BODMAS in school, then you'll know that this should all work out. But if you're just a wee bit worried, you can put in the brackets themselves. As you can see, we're getting them as redundant because, I mean, there's no real read for them because the actual logic of mathematics will protect us here. But if you're just for sanity's sake, you want to put in those brackets, feel free to do so. So this should all give us out the correct parameter and the correct area for a rectangle, as you can see. So you can sort of see where the power of this comes from is. Now, a rectangle is essentially the exact same, or sorry, a square is exactly the same as a rectangle, essentially. I mean, there's no difference whatsoever with a rectangle as far as a square is concerned. So I'm going to just essentially just inherit from our rectangle, and I want to just put this in as length. Okay, now as you can see, now we're getting a weird sort of base thing as well for our constructor here is. This is just sort of saying we're using the base constructor. And since we're inheriting from rectangle, that means we're using this constructor up here. So nothing too crazy. And the nice thing is that we're passing in the length. We can use that for the width and the breadth. So now we're passing in the width and breadth. So width and breadth for the rectangle. Since all of the sides of a square are equal to each other, and essentially a square is a rectangle with all equal sides. So the parameter and the area should be calculated exactly the same. Now with the circle, we have a different, completely different case altogether. So let's have a little look at circle again. And let's type in a float. And of course, you can do it either the diameter or the radius. I usually like sticking with radius, but by all means, feel free to go with diameter and then just divide it by 2 in order to get your radius. It's totally up to you, yes. However, which way you want to do it, that certainly doesn't matter. Just as long as it gets the correct answer, that's all we're going for. So, okay, let's go again with the public virtual, no, not virtual, sorry. I do that all the time, yes. It's an override we want to do, and we want to override, oh, oops, it is. So, okay, we of course need to inherit from our shape. Otherwise, it's not going to give us up that we can override area. And as you can see, and there you go, you can see we can also get, although this is completely redundant code is, we can return base.area, which essentially means that we would call whatever the area is of the base class. So if we were to do base.area, we would be calling our width multiplied by breadth, which is fair enough. But of course, we don't necessarily want to do that, is we want to do our own sort of calculation. So what we want to do is mathf. This is a Unity specific class. Yes, if you're using just standard C#, you can use system.math, and I'm pretty sure it'll have similar properties that'll help you. So what we want to do is, of course, get pi. And if you remember from mathematics, in order to get the area of a circle, you multiply pi by the radius. Oh, why is that coming in? Not sure what's going on there is, unfortunately. Probably because I'm not necessarily doing it correctly. So, okay, we should be fine here. And then we also want to square that as well, okay? So we can use this mathf.pow. So that there essentially means that we're going to multiply this by the power. So the f is the actual float, and raise it to the power of 2. Yeah, absolutely is. I mean, you could by all means draw this, write this out, twice. So this, and then multiply it by this, multiplied by itself. But this way, I just prefer this a lot better. And then we want to return this, of course, which is superbious. Okay, brilliant. And then in order to get the parameter, or otherwise known as the circumference in terms of a circle, we have to do pi d, which is essentially this, multiplied by the radius, and and the radius itself needs to be multiplied by 2. Now this time we actually do need to put in our brackets here because we of course want this calculation to happen first, and then we want the overall calculation to happen afterwards. So that all works out perfectly there. And that's it. Now, I mean, as you can see, there's a lot of code here, which is fair enough. But if we go here, well, we can't necessarily use var here. I want to use shape. And we'll just say shape. We can set that equal to circle. Give it a float, or give it a length of, well, say 5, I suppose. And then we can, well, log out the actual area. ToString.log. Perfect. But then again, yes, we can also change it up. So we can do shape equals new rectangle, and then we can put in it's basically a square, 3, 4, and we can do shape again, dot area, dot ToString, dot log, and then we'll see what we get out. Okay, so let's go back into Unity and make sure we drag our script onto any game object in our scene and run the game. And you'll see we get the area of 246 and an area of 12, since 3 multiplied by 4 is 12. And I believe that's correct for the circle. I'm not 100% sure. That does seem very, very large though, yes. Let's go to Google and area of a circle with a radius of 5. Perfect. Okay, as you can see, I've messed up somewhere. Oh dear. Okay, so what have we done wrong? I say we. What have I done wrong? Yes, I am the issue here. I'm pretty sure the area of a circle is pi rd, or pi r squared, sorry. So let's go and have a little look. Yeah, pi r squared. Why is that not right? Multiplied by 3.14 to the power of 2. Why is that not correct? Okay. This is why it's always good to have a little double check, Ace. Make sure that your work is correct. I am very surprised that this hasn't worked out for me. For whatever reason, it just hasn't. So hey, let's go and have a little look. Okay, well, okay, what is going on here? Oh, I added it together. That was silly. Pi. Oh, I'm an idiot. I am an idiot. It's, sorry, yes. That was me being silly there, yes. It's, of course, pi multiplied by the radius squared, not, of course, the entire thing squared. Oh, idiot, 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 idiot. Oh, sorry, yes. So hopefully this will give us our 70. Oh, there we go. 78 was 0.53. I believe that was correct. 0.54. Yeah, perfect. So yeah, thankfully Google to the rescue. So there we go. We got that correct. And I do believe that this one is correct. Pi r squared, or sorry, pi multiplied by d. So pi d should give us our circumference. But I suppose we could double check that and make sure. Yeah, we'll double check and just to make sure. The only one that I'm worried about here is of course the circle, just because we are dealing with pi, and pi can be, well, it's not a nice whole number, I suppose. So let's just make sure that we've got it. We will go on to here and we will say circumference of a circle with a radius of 5. 31.42. 31.42. Brilliant. Okay, so that's fantastic. So as you can see, the power of this is pretty amazing. It's not only are we using the exact same variable for different shapes, but we're also just not really, like the actual, our code doesn't really necessarily care what shape we use. It'll still treat it as if we were using whatever shape. It doesn't mind. Now you may be thinking, I mean, that's not, or maybe you can see the use cases for this, but if I was to take all this out and make it a little bit neater, right? I could make it so that we had a method, right? So I'm going to just do public void, oops, public void log perimeter. And it's of course going to bring in its own shape object. And then once we bring in the shape, we just want to log out that, okay? And then we also want to have one for log area. And we want to have this area. Okay, brilliant. Do we even need this? Is that what it's confused? No, converts to numeric. Don't even worry about it. Okay, cool. So with this, now what we can do, instead of having all this other fluff, we can now just do log perimeter, pass in our shape, and it will all work. See this is? Look at this. Yeah? Doesn't care. Doesn't care at all. It'll just log it out correctly. So even if I go back into Unity, which I'm going to do now, and press play, you'll see that it logs it out. Perfect. Yeah, absolutely fine. 14, which is correct, I believe. Yeah. 3 plus 3, which is 6 plus 8. Yeah, that makes sense. Okay. Good. Good. Yes. Trying to do all this coding without unit tests, a bad idea. But as you can see, the power of this thing. Now, if I want to add in a new shape, it's as simple as going down here and going, well, public class, let's do a triangle. Let's have it inherit from shape. And then we can just do, well, whatever we want. Triangle is probably a little bit more complex because, well, you could have triangle and then you could override it, but then you could have, because there's like different types of triangle. There's isosceles, there's right angled. Yeah, triangle is probably not a good one to use, but we can use whatever one we want. As you can see, we could even do this equilateral. Equilateral. Oh my goodness, yes. I honest to goodness, yes, I believe that my that my spelling has become even worse. Equilateral triangle. Right, okay, perfect. So we could do this here, equilateral triangle. We could also create another class called triangle and have that as an abstract version of that inherits from shape if we want to, yes. Really, it's totally up to you because maybe you would prefer to have it like triangle here and then go, oh yeah, well it'd be cool to maybe sometimes use triangle or cast to a different type. Again, I haven't really went over casting yet, but I would say for now, I'm just happy enough to just sort of say, okay, equilateral triangle, that'll do me for now, and we'll leave it at that. So, okay. So we know an equilateral triangle has all sides the exact same, so all we have to do is similar to the square. We just type in float, type in a length, store that length, and then we want to, for the area, we want that to be, well, certainly the parameter will be easier, or perimeter will be easier. Perimeter of this is, override, of course, is float and perimeter. No? Why am I not getting that, yes? I'm sure there's a very good reason for it, but hey, whatever. So return, and then we just want length, essentially multiplied by 3, which should give us that. So if I had a equilateral perimeter of a equilateral triangle, length of, say, 4, 3a, of course, as we knew. So 4 would give us 12. So essentially exactly what we thought. Okay, so let's try area. I can't actually remember how you get the area of an equilateral triangle. I believe, no, I don't. I'm not sure. Oh my goodness, okay, that's quite the area of an equilateral triangle. Okay, so let's get this one, let's break this one down, because this actually looks like a pretty good equation to try and plug in to our C#. So override, and let's do a float, and let's have a area. Let's do get, return, and okay, so what we have is we want the square root of 3. In order to get the square root of anything is, you can use mathf.squared, I believe it is, yeah. So square root of 3 divided by 4. We also need to put our f on the end is just to make sure that we're getting out the correct equation. Make sure that it's not trying to truncate our float, if you remember. And we want to multiply that by a, and the a, of course, is our length. You by all means can put in A here is. I just want to stick with the length. I'm happy enough with that. But it's the length squared. So we can do either length multiplied by length here, which is length multiplied by length. Oops. Like so. Or of course we could do the pi. So the mathf.pi. Totally up to you, yes. However, which way you prefer doing this thing. I mean, really, it really depends what you find easier to read. If you find length multiplied by length easier than mathf pi blah, that's totally fine. If you don't, then I guess, well, don't. So we're looking for an area of 6.3. So now I'm going to go back up to here, and now I want to log out our parameters. So as you can see, we can just simply go in here, do our equilateral triangle, plug that in instead, and length will be 4, of course. And then we can do this log area, equilateral triangle 4. So let's go back into Unity and replay the game. And hopefully we should come up with 6 point something. Was it 6.92? Was it 9.3? Perfect. And 12, because 4 plus 4 plus 4 equals 12. Brilliant. Yes, brilliant. Okay, so now, yeah, fair enough. Good. But you may be thinking to yourself, well, yeah, but I mean, it's still a wee bit, there's something we don't like about it, or maybe it's a little bit annoying having to go and put that in. Okay, well, how about we create an array of shapes? Oops. Create an array of shapes, and we'll populate that new array with our newly, we'll just type in shapes here. And we're going to populate that with our circle, and we're going to populate that with our rectangle, and we're going to populate that with our equilateral triangle. Yes. Easy peasy. Okay. And then we're going to delete that, and we're going to put in a for loop. Why are you coming out with a problem there? No base type found for an implicitly typed array? Excuse me? Oh, okay, you have to actually put that in, but it was coming up with it being redundant. Didn't necessarily matter, but I guess it really does matter, yes. Hey, fair enough. So, okay, let's put in for each shapes and shape. And then what we want to do with this is we want to log out the parameter for the shape. And we also want to log out the area for the shape. So if we go back into here, is you can see that if we press play, we can get out the areas of the respective shapes. Now, as you can see, you're thinking here going, is that a rectangle? Is that even, look, as you can see, both of these are two different. That one's the area and that one is the parameter. Hard to tell. Hard to tell, is because the actual logging systems that we've got in place here aren't necessarily being that descriptive. So of course we can do this and, oops. We can do this and add in a parameter. And we'll just even make it like nice and easy here. Just add this into there, which of course will work. It'll make it look a little bit better. But of course we don't necessarily want to do just this. Is while it is nice having our parameter and area logged and being able to differentiate between them by doing this, which we do now. If we compile quick, come on, perfect. So now you can see parameter, area, area, perfect. But we still don't know what the actual shape being logged is. So now what we can do is go in and override the toString method. Now this is pretty cool, yes. So we go to return, and we want to return from this, we want to turn triangle. Actually, we need to be probably a wee bit more descriptive with that, so I'm going to do equilateral triangle. Perfect. And then for our rest of them, we want to have circle. You can see where we're going with this, yes. Easy peasy. Just quickly skip through it. Nothing too crazy with this. Kind of easy, kind of breezy. No real issue here. Oops. I guess I'll just type that one in. So now what we can do is, instead of just having it like this, we could do shape dot toString. Actually, just so that I don't have to change the formatting, I'm going to do this here. Probably not the nicest way to do this is, but I just think it's going to be a little bit better for us in the long run. So what I want to do is have area here, and then I want to do, yep, this. So as you can see, it'll do whatever the first one was, which is going to be our shape to string, and then the, or sorry, not first one, the second one, and then of course the first one will be our area, and we will do it like that. I kind of want to do this a little bit more, something like that. That looks a bit more nice, bit nicer in the long run. Yep, perfect. Okay, perfect. And then as you can see now, if I go back in, we can see what we're actually getting the area of. So if we press play, it should, with any luck, come up with circle, rectangle, and equilateral triangle. Look at that, is perfect. So now you can hopefully see the power of polymorphism. It's pretty darn good. And now look at this shape. You can see what's happening here is, as you can see, we're sort of repeating things. I don't know if you watched the, I don't know if you've been watching the Pokemon making let's make a Pokemon ROM that I'm doing on the channel, but a lot of these, whenever I'm doing any of the refactoring or rewriting of the code, there's certain little, they call them in the agile world code smells. So as you can see, shape dot blah. Is there any reason for this log parameter to be here? Would it not be nicer to take this away and to put it instead inside our base class for shape? So if we went into here and did this instead, now we wouldn't have to do shape because we've already got the parameter and we already know the toString, so we could just do that instead. Same with the log area, we could just take that out, put it into here, and we could take away the shape, take away shape of course, and then instead up here what we do is just go this, shape.log parameter, shape.log area, take away shape, going back into the log area of course, because since I didn't actually take it away, just leave it at that. Is you see how important this is? You see how nice this can make your code? Look at this, like what was once a pretty, I want to say pretty shelled out class is just simply reduced to this. I mean, you could have your own sort of shapes class, I suppose, that would go through all the shapes independently. You could probably even make a method just here, shape.log log key length or log key values, I suppose, which would just automatically go through and just log the parameter, log the area. We could definitely take out this here actually. Kind of want to do that maybe now. I will do that now then. Let's go. We'll extract a generic sort of method and we'll call it get value for the moment, and we will pass in a string and string, I want to say values name. The value name that we were going to use is area, and then we also want to put in, oops, this could be 2, I suppose. We could just do that, yes. Value name. And then we could also put in, do we want the area to be there? No. So I suppose we could instead do, you can see where we're going here. So you can see how annoying this is. How annoying it is to actually put in, let's say the value here. The actual value itself. This is because we've got something known as primitive obsession going on at the minute. I'll discuss that in a little second with you. Basically what it means is, because we're just using floats everywhere, because we're having to pass in a float in order to represent itself and to get its own string value, it's sort of thinking, it's as if the code is trying to tell you this should probably be its own object. You know, maybe you should have some sort of area object, so it would go in and just, you would be able to pass this in as the actual thing itself, or even it could just be some sort of value object, like shape value object. So that perimeter and area would be a shape value object, and both would inherit from that instead, so that you could just use it like this, the way that we're currently using it. It's one of those things, yes, we're not really sure, because then instead of this here, you could just pass in this shape value object, and it would have the name of the actual value's name and the actual value corresponding to it. But yeah, we'll say for the moment. This is where you can take this thing to the next level, Ace, and go maybe a wee bit too crazy with it, but I'm not sure. It's always one of those ones, Ace. You can spend the rest of your life refactoring a piece of code. But here you go. As you can see, now we've got a much more generic method going on here. Much nicer, as you can see, because everything's sort of, and then we could just do log value instead here. Log value. Could even make that private, which it is. Okay, brilliant. There you go, log value. So now any sort of everything else, so if we had parameter, area, I guess the other ones would probably be, I'm not really sure. Area, parameter, you could probably get whatever sort of other shape-like things that you wanted to do, you could log them out as well, and it would have a nice sort of working method with it. Again, a little bit of bonus refactoring while you're learning about polymorphism is, but hopefully you can see just how powerful this is. So you could put these out and make them into their own respective classes and leave it at that. Yeah, I mean, really, it's kind of brilliant. It really is really cool and extremely useful. So I kind of want to show you, I don't really want to do that seal thing. I remember the docs were talking, yeah, I remember the docs talking about actually being able to seal the class and not override it. By all means, yes, feel free to do that. I personally never have done that, but I could understand why that would be somewhat good. I don't know. Whenever you're sealing methods like this, I don't know, it feels like a design smell to me, but maybe it's not. I don't know. Maybe it is. Maybe it isn't this. Maybe I just don't necessarily use that stuff, whatever. I'm kind of okay with that. And another thing as well is this new, so you can add in a new, so if you put in new here, it won't override area. It'll instead just create a completely new, it'll just create a completely new method called area. So that if you try and inherit from equilateral triangle, that's completely changed it for you. Let's call that L. We shall say, why not? Yes, that's no bother. And then now if I try and put in area, I don't believe I can do that. No. If I do parameter, can I still do that? Yep. As you can see, we can still override parameter, but now I can't override area. Area is completely gone. So even if I went public override area, we wouldn't be able to do it. Okay, oops, float area get, yeah, return 0. As you can see, we get the error. There's no suitable property for override. So even if we, I wonder if we did new, could we do that? We could do new. Okay, interesting, because it's also saying that the keyword new is required on area. So yeah, I mean, it's not too bad, I suppose. If you want to do that instead, you could. It's a form of polymorphism, I'm sure. I've only ever really used virtual and override here, so I'm not sure if there's any real performance benefit for new. So the Microsoft docs have a pretty useful document here about knowing when to use override and new keywords. Now, I must admit, after reading this document, it doesn't really seem like there's any advantage over either. I would expect the new one to perform quicker, since it doesn't have to do the same sort of lookups that the override has to do. But again, yes, I could be talking absolute baloney there. Anytime I've ever done this polymorphism stuff, yes, I've only ever used override. I've only ever used virtual and override. So by all means, if you prefer using new, I would say it's probably personal choice. I'm sure, believe me, if there's a concrete reason why you shouldn't or should use override instead of new, please tell me in the comments. But as far as I can see, there's no real reason to do so. But yeah. So yeah, I think we've done a pretty darn good job, Ace, of showing you exactly how this all works, polymorphism. We even went into the base constructor stuff, which was pretty cool too. And yeah, I'm kind of happy enough with that. So I think I'm going to leave it there, Ace. So yeah, rate, comment, and subscribe. Yes, I hope you've enjoyed this polymorphism walkthrough. You can email me at retrotk2@gmail.com with anything you like. I'm sorry it's taken so long to do another C# video, so I'm going to have to make sure that the time frames between them is not as long this next time. Thank you for watching this, and I'll see you in the next video.